All right, not drawn to scale, but this is a square. Okay. The radius, the sides, let's make them, say, 4.5 meters apart. A coulomb is a large amount of charge. Okay, a coulomb is a large amount of charge. We should get a decent force here. All right. So 4.5 meters along each side. Please find for me the sum of the electrical forces on that bottom right-hand corner, 2.5 coulomb charge. Now, a word of warning in doing this. I recommend drawing a free body diagram, okay, for what you expect to have happen. Because gravity, the forces always went which way? Pulls in, right? Is that the same with electric? No, they can pull in or they can push out, right? It can do either one. So a free body diagram here is going to be oh so critical of what we expect to have happen on this 2.5 coulomb charge. All right, so this bottom right-hand corner 2.5 coulomb charge. Negative and negative, repel or attract? Repel. So whatever I figure out the magnitude is for the force here, I'm going to make it go straight down. This is the force from the negative 2.5 coulomb guy. It repels, it's going to go straight down from that 2.5 guy. Yeah? Okay. Let's do this one over here on the left. Positive 3.2, negative 2.5. Okay. Attract. So it's going to come over like this. Force of a 3.2 pulling it over. Right? Don't forget the other one up in the corner. Positive, negative. Attract. So it's going to come up like this. I'll have another force of 3.2. Okay? Going up like that. You might need to label these some other way so you don't get your 3.2s confused. So maybe I'll label this A and this B so I don't get things confused. 3.2A, 3.2B. Okay? And then you're going to use Coulomb's law, right? Force electric K Q1 Q2 over R squared to figure out the magnitudes of those forces. Right? Figure out the magnitudes of those forces. Then you're going to add the vectors, just like you've always done. Let's think about angles collectively together. The negative 2.5. What angle is that one at? 270. The 3.2A. Which one's that? What angle is that at? 180. 3.2B.
135.
Good. 135. How'd you get it?
Well, it's a square, so you know all your angles from the 9, so half of the 9 is 45.
Right, let me give a bisecting line right there. Yeah? Here's a right triangle with two sides being the same. Right, an isosceles right triangle, meaning this angle is 45 degrees. Meaning that angle is 45 degrees. Does that make sense to everybody? It's a square that bisecting is perfectly in the middle there. And if it's a rectangle, it might not be perfectly in the middle. But since it's a nice square, this. Okay, so this is 45. Meaning the angle for 3.2b measured back around to the positive x-axis is 135. Emily?
So you are saying the squares, all four sides are all the same?
Yes. All four sides are the same. As denoted by my little lines there on each one. Okay. Another thought for you.
Oh, those are plus.
You have to have the radius in this equation, right? Between the charges, the distance between the charges, well, the distance from the negative 2.5 to the negative 2.5 is easy. It's 4.5 meters. From the positive 3.2 A over to the negative 2.5 is easy. 4.5 meters. How about from B over here? How would you figure that out?
4.5 times square root of 2.
Good. Yeah, it's going to be Pythagorean theorem, right? Does everyone see the Pythagorean theorem here?
Yeah.
Yeah? I've got a nice little right triangle. There's one side. Here's the other side right here. Here's a hypotenuse, you know, coming along like that. There's a hypotenuse, and the hypotenuse of that triangle, of this nice little right triangle here, is going to be my radius between them. All right. So give you a second to go ahead and solve that. Add the vectors, by the way. I'm expecting an angle somewhere in quadrant, I don't know if I had to guess 3, right? I could expect something closer to 3 and 2, so I'd expect, you know, it's got to be greater than 135, right? And it's got to be less than 270, yeah? So it's got to be in quadrants 2 or 3, which means you're going to come out with a negative x component. Whenever you total them all up, a negative x component means you got to do what's the final angle your calculator gives you?
Add 180.
Add 180. Okay, fix that.
Good.
Somebody copy those numbers down again. Do we have any
You're not sensing it.
10 to the 8 is what some of you got for B?
It's pretty much gonna be.
All right, let's work B out just because that one has controversy. What I have labeled as A up there, we got 3.55 times 10 to the 9th newtons, and that's at 180 degrees. All right, let's come back up and look at it and double check, right? A pulling at 180 degrees. Now B, we're saying we've got a few problems on here. So let's actually plug the numbers through and work it out. Force electric, K, Q1, Q2 over R squared. That's going to be K times 3.2 times 2.5, right? Those two charges. Bear with me. Once again, I am dropping the negative, so I don't overcorrect what I'm already going to do with the angle. Okay, divided by the distance between them. How do you find the distance between them?
I did square root of 2 times 4.5.
That should be fine, right? Square root of 2 times 4.5. Those of you who got times 10 to the 8, please type in square root of 2 times 4.5 and double check that the answer you have for radius is the same as that. Different? Different? Okay, let's actually go through that. That's the shortcut we have, right? Let's actually go through the Pythagorean theorem to make sure what we're doing is okay here. The Pythagorean theorem says that my radius here, squared, should be equal to the two sides squared. And the sides are 4.5 meters. So 4.5 squared plus 4.5 squared. Right? So 4.5 squared plus 4.5 squared is 2 times 4.5, right? So this is R squared equals 2 times your 4.5 squared. Yeah? Am I right with that? I mean, plug it into your calculator. Do we need to use numbers instead? Okay, so, and then I'm going to square root. So now, R should equal square root of 2 times 4.5. What does R come out to be if that's
6.36?
6.36 is very reasonable. 6.36 meters is very, very reasonable. Is that what everyone came out with for R? Yes. Okay, so this is divided by 6.36 squared. All right, please plug that into your calculator. What do you get? Make sure to use the right K, not Boltzmann's constant. And we're not dealing with gases. We're dealing with electric charges. Coulomb's constant. What'd you get, Bailey? 10 to the 9th. And we already figured out that was at 135 degrees. Yes? Okay, we'll take this as our answer right now. 1.77 times 10 to the 9th newtons at 135 degrees. And now we need C. And C we already figured out was 2.77 times 10 to the 9th newtons at, back up, 270, right? Because it's
Correct.
propelling. 270 degrees. Are you okay with these forces? Yeah, so here are our vectors that we're going to use. There are the vectors we're going to use. Divide the components, add x's, add y's, Pythagorean theorem, inverse tangent. Okay? So, coming down here, my x's. X total equals A 3.55. Let's add this vertically. I think that'll be easier room-wise. X total is going to be 3.55 times 10 to the 9th. Cosine my angle, which for A here was what? What was A for the angle? 180. 180. Right? B here is 1.77 times 10 to the 9th cosine. Please give me that angle, Emily. Don't. All right, Scoggin. What's the angle for B, please?
For B, it's 135.
135. And then C, 2.77 times 10 to the 9th cosine 270. And so I'm going to add all those up. Please give me my x total. What's that going to be? Should be negative something.
Negative 4.88 minus 1.8.
All right, give that to me again, Austin, please. Bailey?
What is the cosine?
McKinley?
I was looking at
Negative 4. Negative 4.9 times 10 to the 9th. All three of those added together. There is no reason, if you don't remember about adding vectors, there is no reason except you want to make life a lot harder to add two of them, go through the process of getting that resulting vector, right? And then break it all back into components again, and add the third. That's you got rocks in your head. Not to be mean or anything, okay? But please don't do that, okay? Add all three of them together, and it's so much easier. Now, y total.
negative 1.49.
For A, 3.55.
180.
Hey, what are we doing here, guys? Arguing about that bottom number for X total?
I kind of do this.
For Y total. That's what we're arguing about. Okay, how far off are y'all from each other? My goodness. Let's see. Point 1 is well within the margin of error here. Okay. B, let's see, 1.77. I forgot my times 10 to the 9th here. I apologize for that. Times 10 to the 9th. Sine of 135. And then C, 2.77 times 10 to the 9th. Sine of 270. Okay. Arguers, what is it?
1.522.
Negative
1.522.
1.52 times 10. Negative 1.52, 1.53, 1.51, plus or minus 0.01.
I got negative 5.7. 1.48.
If you came out with anything around that plus or minus 0.1, we're good. Okay? Look, it's rounding in your calculator. Some people stored, other people didn't. Some people rounded throughout all of this to 3 decimals. Some people rounded to 5 decimals. Some people did a little no-no throughout this, but it's such a small no-no that I don't get on to you, and they just truncated all throughout this. Okay? That means just cutting it off. Okay? I don't get on to you about that, about truncating, as long as you're truncating so far back that it all ends up not mattering. Okay? Just don't truncate it like the 1 and 4, okay? That's bad, that's bad. All right, so now I have an x total and a y total. That's awesome. Pythagorean theorem will give me my resultant here. So R equals the square root of, and whenever you're punching this into your calculator, dadgum use parentheses, because many of your calculators aren't idiots. And that's well known, by the way. That's why you need to know your multiplications table and have things memorized like that so that you can fix your dumb calculator's mistakes. But anyway, negative 4.9 times 10 to the 9th squared plus negative 1.52 times 10 to the 9th squared, right? You have to realize what's going to be happening here basically, right? The negative squared gives you a positive, but using parentheses around that, sticking the square on the outside should be fine. To double check whether your calculator is one of the dumb ones or not, type in negative 2 squared and see if it gives you negative 4, right? So see what happens there. What does R come out to be, please? .03 times 10 to the 9th. If you got 5 something, right, or 4.9 something, whatever, we're good. Okay, we're good there. I need to get myself an angle. How do I get an angle? Good, inverse tan, right? So, take all this, move it over. Theta equals tan inverse of y total divided by x total. Right? So take your y total divided by x total, take your inverse tan. What does my theta come out to be? 197. I only got 2. Let's write down mine. 197 degrees right now. Alright. So we've got to deal with sig figs here, right? So this becomes, so 5.5, this becomes 5.0. 5.0 times 10 to the 9th newtons at 200 degrees. And you can use a line to notate where sig fig stops, or you can put it in scientific notation either way. You could do 2.0 times 10 to the 2nd, right? Scientific notation is just fine. The line over works too. The only reason you got to be careful with the line over is you don't need to make this mistake right here. The line over works if it's a 0 that's not at the end. If I wanted to designate that all 3 of these zeros were significant, what would I need to do? I'd have to put a decimal point, 200 dots, right? Because, and really this doesn't matter, but if I did this, 200 with a line over it there, what in math does a line over the last number mean? Yeah, it repeats forevermore, which a bunch of zeros on the end, without a decimal there, I mean, this is getting really weird. You know, generally you only see this in math whenever you get like 200.3 line over repeating 3's from there on out, okay? But make sure if you're going to use the line that it's not going to get confused with that math term, okay, for repeating forevermore, okay? Any questions about this problem? Any questions about this problem? None? All right.